Star Trek, I had a TV dinner, and then I would work on my own fun projects in electronics. I would have my own life. And I started getting a reputation around California that there was this 20-year-old guy that would design products for you if you needed some design done. I designed the first hotel movie system for the digital part. And I designed time codes for television recorders. And I designed all these neat, cool things all life that even when I could build my own computer, I could never afford good input-output that you could type on or see things on. And all of a sudden I realized the output device, we all have a television at home. And I know everything about television electronics and television signals. One little wire can carry a signal into a television that displays anything I want. And I also have the ability to design with chips anything I want. So I designed a home game. And it put signals on a wire, up and down voltages that told the television how to work and where to display. First, video games on television displays, you know, for arcades and things like that, all started with Atari, and they were in Los Gatos, California, where I live now. I am so proud of that. Los Gatos, California is also famous for the invention of a device called the Pet Rock. If any of you ever heard about the Pet Rock, it's a famous novel. Anyway, I would go down and visit them before they ever came out. How much fun there was in this life we were living. Eventually we created a game for Atari called Breakout, and I could do it in 4 days. I didn't think I could do it. I was the hottest in the world at designing things, but I didn't think I could do it in 4 days. We went 4 days and nights with no sleep building this device. We delivered it to Atari, working, and we both got the sleeping sickness, mononucleosis, from that experience. But I'm so proud of it. Something interesting happened to my head while I was working there. All of the television sets they were using were black and white. But for some reason, there was a dot going back and forth on one of the TVs. And by the way, they had no microprocessors in the games back then. A little dot going back and forth on the TV, changing color. Red, blue, green, yellow. Red, blue, green, yellow. Red, and I'm thinking, the color TV must have had Mylar coating or something. I was so tired. I could hardly stay awake. I could hardly keep my eyes open. And I went back to a bench and I thought, what is color television signals like in American and line or shape? It thinks it's lighter or darker or a different color. And then I thought, oh my God, I'm in the digital world too. I'm in the analog world, I'm in the digital world. And my head was so free. It was near falling asleep, half asleep and half awake. And what popped into my head was the thing that had never been in any book on color television. Books describe how you generate color television with all these sine waves, these nice waves and mixtures of the red, the green, and the blue at different amplitudes. And you could create the final signal with a $1,000 board. You could create color television in the books. And I thought of this little $1 chip. It had 4 little ones and zeros in the chip. It's called a shift register. And if I repeated those ones and zeros, I would have a signal that went up, 1, 1, down, down, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0. You see the similarity to those waves going up and down? Because I knew how every television was built in the world, I knew that my little signal out of this $1 chip that would have 16 different color codes, that signal was going to be interpreted as color by every home TV. It had never been done in a book that way, so it was a really amazing, genius invention, and I'm glad that my head went to the right places. Eventually, shortly after that, by the way, Steve Jobs sold that one to Atari for us too, and we got paid. And the next thing, I saw somebody typing on a teletype, and he said he was typing to a computer across the country. You could pay for local time-sharing signals, where you dialed a number and typed programs into time-sharing, but he was typing one for free to 8 universities: MIT, UCLA, UC Santa Barbara, Utah, and Stanford. A bunch of universities. You could pick your university, and you could see data that they shared. You could log on as a guest. You could run programs even. Wow. I was startled. He was typing on the big teletype machine that I could never afford. But I said, I have to have this. I have to have this ability. It's like Superman. And what popped in my head was, I'll just go home and build a little board, maybe with 30 $1 chips or 40 $1 chips, and I will make it, put out the signals to my TV set to display letters of the alphabet. And I'll buy a keyboard. The keyboard was very expensive back then, much more than even a microprocessor ever turned out to be. Much more than the memory we used turned out to be. I bought the keyboard. In those days it was expensive. I could type on my keyboard, put the signals as tones over a phone line. It's called a modem. And I could call a number local at Stanford. And that put me on the ARPANET. And now I could bring up all these computers across the country and use them live. Now I was working at Hewlett-Packard building calculators, a machine that you take out of the box, you turn it on, and you start pressing buttons. How did our calculators work? Well, inside they owned a computer with a microprocessor chip. And it needed some memory. And I did the right kind of memory where everybody else was doing the wrong kind, because the people making these products weren't intelligent engineers. They were just copying data sheets that Intel passed out of how to make a microprocessor work with memory. And they weren't thinking of choose the right kind of memory, it's 1/4 the cost. And yes, you have to do a little engineering work because it's harder to use dynamic memory. But I did use the right kind of memory. And I put in 2 little chips that held a 256-byte program. We didn't get very many bytes on chips back then. 2 chips held a little program that looked at what I was typing on a keyboard. And what's he typing? And when I pressed a T, it put a T in memory. When I typed, an O, it put an O in memory. When I typed an M, it put an M in memory. And then when I hit return, the program said, what did he type? What sense does it make? And maybe I'm putting data into memory. Maybe I'm telling my television to display the data in memory. Maybe I'm telling it to run a program at a certain address. And this was the computer that I built. Well, Steve Jobs was not around, by the way. He didn't see this. And all the people in our computer club were talking about that message on a big computer, and within an hour, 100 other people could dial into the... If you go back and look at the Apple I computer, it was the first time, especially if you saw the small board I had, which was a lot less than the actual PC board of the Apple I computer, it had so few chips, and it was doing every bit for the personal computer was out. Everyone looking over my shoulder saw the formula. Every computer before this one had a front panel with switches for up and down, and buttons to push. Every computer after this one would be video display and a keyboard. That was all these little silver metal traces put on it to wire up the chips. It cuts a 20-hour wiring job, and he had retired at a fairly young age. And he was looking around for new investments and new projects, and he came to the realization that what we had, that this home computer market, as we called it then, was going to make a company, $1 billion company, in 5 years if they had graphics. What graphics mean? It meant that a microprocessor could change 1 million numbers in memory a second. 1 million a second. And each one of those numbers is a dot on a computer screen. For the first time in history, you had a machine, that very low-cost machine, could change 1 million dots a second on your television. That meant that games would no longer be hardware. They would turn into software. And when I wrote my first games in software, I got chilled. I'm getting the chilled feeling right now talking about it. I was chilled. Now the games are software, it's going to be a whole new world, because you can do more work on a game in half an hour in software than you can in 10 years making hardware changes, resoldering wires. This was an incredible discovery. Both Steve and I knew we were onto some big stuff here with this Apple II computer, and we put it out, a very open machine. It had 8 little slots you could plug your boards into, and you could design boards that controlled motors, that ran relays, that had sensors that came in, that had more memory. You could put your own devices into our computer. We made it so easy. I put out every piece of code I'd ever done. It was called the WOZPAC. Every piece of code on it I'd ever written as examples. I wanted people to learn how computers were made from this product, because I had learned how computers were made by looking over other people's manuals, their listing, their software, their hardware. And we had a president, Mike Scott. Mike Margola, our investor, told us, here are the sort of people you hire to have a company. You need accounting, here's what they do. You need a president, here's his role. You need this. He defined all the roles and who we had to hire. He really established Apple as a business. He told Steve Jobs that Steve Jobs' role would be just to kind of, Steve didn't have